Picture this. You're standing outside on a perfectly clear night, looking up, and everything feels frozen. The stars look fixed in place, like they've been pinned to black velvet since the beginning of time. Space feels like the ultimate still life. Quiet, empty, unmoving. That feeling is a lie. A beautiful, convincing lie. Because right now, somewhere out there, entire galaxies are ploughing into each other. Hundreds of billions of stars colliding with hundreds of billions more stars in a slow-motion demolition derby that's been playing out since the universe was young. And one of these collisions isn't some far-off curiosity. It's got your name on it. So let's talk about what actually happens when two galaxies collide. Because it's stranger, slower, and somehow more violent than you'd think. First, let's kill the image you probably have in your head. You're picturing something like two cars smashing together, right? Sparks, crunching metal, instant chaos. Galactic collisions are almost nothing like that. Here's the wild part. When two galaxies collide, the stars inside them almost never hit each other. Not one. Because even though a galaxy might have 400 billion stars packed into it, the actual distances between those stars are enormous. If you shrank the sun down to the size of a marble, the nearest star would still be hundreds of miles away. Galaxies are almost entirely empty space, just dressed up to look solid from a distance. So when two galaxies merge, you don't get a fireworks show of stars smashing into stars. You get something closer to two loose clouds of glitter drifting through each other. The stars slide past one another, tugged and flung around by gravity, but they don't collide directly. What does collide is something bigger and less visible, the gravity of the two galaxies themselves. Think of each galaxy as this enormous, invisible gravitational hand made of billions of stars, gas clouds, dust, and a giant swirling core. When two of these hands get close enough, they start to grab each other. Not gently either. Gravity starts warping the shape of both galaxies, stretching them, curling their edges, ripping long streamers of stars out into space like taffy. These streamers are called tidal tails, and they can stretch for hundreds of thousands of light years, way longer than the galaxies themselves. This is the part that would look genuinely insane if you could watch it from outside, on a time-lapse. Two majestic spiral galaxies, all calm arms and glowing cores, slowly reaching into each other, deforming, twisting, throwing glowing arcs of stars out into the dark, like something being pulled apart in slow-motion taffy pull. It's beautiful, and it's honestly a little terrifying, because you're watching something the size of 100,000 light-years get bent like it's made of rubber. And here's the part that really messes with your sense of time. This entire process, from first contact to final merger, doesn't take hours or years or even centuries. It takes hundreds of millions of years, sometimes over 1 billion. Which means if you were somehow alive to watch an entire galactic collision from start to finish, it would look, at any given moment, basically frozen. Just like the night sky looks frozen to you right now. The collision is happening. It's just happening on a timescale so vast that human civilization could rise and fall a few thousand times over before you noticed real movement. Now, while the stars themselves are gliding past each other untouched, the gas clouds inside each galaxy are having a very different night. Unlike stars, gas clouds are huge, diffuse, and they take up a lot more relative space. So when two galaxies collide, their gas clouds do slam into each other, and hard. This collision compresses the gas violently, and compressed gas has a habit of doing one very specific thing, collapsing to form new stars. So, paradoxically, galactic collisions, these slow-motion, 100-million-year train wrecks, are actually some of the greatest starbirth events in the universe. Astronomers call these starburst galaxies, regions lit up with thousands of newborn stars igniting all at once, blazing far brighter than anything a normal, undisturbed galaxy produces. In a very real sense, galactic collisions don't just destroy structure, they spark entirely new generations of stars and eventually new solar systems, maybe even new planets. But there's another passenger riding along in every galaxy that we haven't talked about yet, and it's the real heavyweight in this whole story. The supermassive black hole sitting at the center. Almost every galaxy, including the one you're in right now, has one of these monsters anchoring its core. When two galaxies merge, their two central black holes slowly sink toward the new combined center of mass, pulled in by gravity and friction with surrounding stars and gas. This can take a long time too, sometimes so long that some galactic mergers are stuck with two supermassive black holes orbiting each other for a while, like some cosmic double star, before they finally spiral together and merge into one. And when two supermassive black holes finally do merge, they don't do it quietly. That collision sends ripples through the fabric of space-time itself, gravitational waves, distortions in space that spread outward at the speed of light. We've actually detected these ripples here on Earth, from black hole mergers happening in other galaxies, using instruments so sensitive they can detect a change in distance smaller than the width of a proton. That's how real this is. The universe is quite literally ringing like a bell every time one of these collisions finishes. So to summarize what actually happens, the stars glide past each other almost entirely undisturbed. The gas clouds crash together and spark firestorms of new star formation. The overall shapes of both galaxies get warped, stretched, and torn into sweeping tidal tails. And deep at the center, two supermassive black holes eventually meet and merge, sending gravitational shockwaves out into the cosmos. Given enough time, the two galaxies stop looking like two galaxies at all. They settle down, the tidal tails fade, the frantic star formation slows, and what's left is usually a single, larger galaxy, often a smooth, football-shaped elliptical galaxy, a calmer, older-looking structure built from the wreckage of the collision. Here's where this stops being a distant cosmic curiosity and becomes personal. Your galaxy, the Milky Way, is on a collision course right now with our giant neighbor, the Andromeda Galaxy. Andromeda is currently barreling toward us at about 250,000 miles an hour, and in roughly 4 to 4.5 billion years, the two of you are going to meet. When that happens, all of this plays out again, but this time it's your night sky doing the twisting. Andromeda will loom larger and larger over tens of millions of years, eventually filling huge portions of the sky. Its spiral arms visibly warping as gravity starts pulling both galaxies apart and back together. Stars will slide past stars, untouched. Gas clouds will slam together and ignite fireworks of new star birth. And deep in the core, our supermassive black hole and Andromeda's will begin their long, slow orbital dance toward an eventual merger. The end result, billions of years from now, is a brand new galaxy that astronomers have already nicknamed Milkomeda. Neither the Milky Way nor Andromeda anymore. Something new, born from the wreckage of both. So next time you look up at a sky that seems frozen, still, unchanging, remember what you're actually looking at. A universe that's constantly colliding, merging and rebuilding itself, just on a timescale so enormous that stillness is the only thing you're capable of perceiving. Somewhere out there tonight, galaxies are quietly crashing into each other, sparking new stars and merging black holes. And one day, your own galaxy is going to join that ancient slow-motion dance too.